Welcome to the channel RK Learner. Now we are having a question. In figure, a system of 4 capacitors connected across a 10-volt battery is shown. Charge that will flow from switch S when it is closed is. Let us see what happens when I close this switch. Okay. So I'm simply reconstructing the same picture on the right hand side. Okay, so please wait. Let me complete this picture first. Okay, so here is one more capacitor, and I'm having one more capacitor here and here. Right. So this is how it is looking like. Okay, we shall don't leave the battery. The battery is here. Okay, so battery is 10 volt. What I do is you can solve in many ways. And now I treat what I treat. It's 10 volt. I split it like this: plus 5 volt and minus 5 volt. That means the right plate, I mean left plate of this capacitor, this one and this one. These are what? These are what? Plus 5 volts, plus 5 volts, and the right plates of these two capacitors are at minus 5 volt, minus 5 volt. Okay, so now we are having what? We are having two other points. One side it is A and another one is here, somewhere it is B, right? So this is what we are seeing in the picture, connected by a unconnected switch, right? So opened switch is here, so I don't show it here now. So further, what I do is, now we have to know what the potential of the right plate of the left capacitors and left plate of the right capacitors. So that is should be found. So to find that, what I do is I simply connect. When I close the switch, yes, okay. So when it is closed, the switch is closed. So it becomes like this. So when closed, when yes, closed, right. So this happens. That means that means this whole system now appears in a different way. The left two capacitors are in parallel, and again the right two capacitors are also in parallel. To find out the effective capacitance, so that we already know the capacitor is 2 microfarad and this one is 3 microfarad. This one is how much it is? 3 microfarad, and this is 2 microfarad. So for the right branch, it is 2 microfarad and 3 microfarad. These two are parallel, right? So these two are parallel, and these two are again parallel. They are having the same values. So when I'm having the same value, so how I can treat? I can simply do what? I can simply go for a kind of calculation like this. It is a C1 plus C2, and again on this side I'm find out a C1 plus C2. So definitely CP is equal to, so it is a 2 microfarad plus 3 microfarad. This comes 5 microfarad. Again, it is true on the right hand side, the branch, or okay, parallel branch. 3 microfarad plus 2 microfarad, again it gives me 5 microfarad. That means the set of capacitors are left side and right side are with the same effective capacitance. Effective capacitance 5 microfarad and 5 microfarad. So that means the potential difference for the right set of parallel capacitors and left side of parallel capacitors remain same. So equal potential difference. So to prove that, what we do is okay. So I simply consider the potential of this plate. It is 0. So now the potential difference for this capacitor becomes plus 5 minus 0 is 5 volt. So this is a 5 volt. And same is true for this one because these two are parallel, right? So this one is 5 volt. Okay. So on this side, it is the left plate again at a 0 volt. The potential difference is a 5 volt. This plate is again at a 0 potential and this is also 5 volt. The potential difference is 5 volt. Okay. So here is 0 and right plate is minus 5. The potential difference becomes 5 volt. So now you can observe carefully the right capacitor, or the left capacitor, which one, whatever you take, nothing happens. Let me consider first this one. So please wait. So I am considering this capacitor. Okay. So I consider this one. What we can do now, it is 2 microfarad and a potential difference 5 volt, right? And a potential difference 5 volt. So what it gives, now I can find out the charge in this capacitor. So how much the charge that can be stored? It is right, 2 microfarad, which is equal to the charge in this capacitor, right, divided by 5 volt is the potential difference. You can simply say this is a 10 microcoulomb charge. 10 microcoulomb charge. And let me do for another one, where it is here for this one, for this one. It is 3 microfarad, right? So it is 3 microfarad, that is equal to charge divided by how much? 5 volt again. So this Q is equal to 15 microcoulomb. 15 microcoulomb. That means this upper capacitor is storing 10 microcoulomb and lower capacitor is storing how much? 15 microcoulomb. Well, let me zoom it. Okay, so let me zoom it a little. Just observe carefully. So what is happening? I already closed the switch, right? So this one is now processing 10 microcoulomb charge. 10 microcoulomb charge. See how beautifully it is storing the charge. See carefully. See carefully. It is plus 10 microcoulomb on this side and minus 10 microcoulomb on this side. And this another capacitor which is already set in the bottom, right? So this is storing how much? 15 microcoulomb. This is a plus 15 microcoulomb and this one is minus 15 microcoulomb charge. When you observe carefully, the left set of parallel capacitors, these two, are in the same pattern. Again, in the same pattern. Uh, this one, the upper 2 microfarad is identical to the lower right capacitor, which is 2 microfarad. Okay, so this one. So that means this capacitor again must store how much? So it also stores plus 10 microcoulomb on this side and minus 10 microcoulomb on this side. And meantime, we can do the same thing for this one upper capacitor, because this upper capacitor 3 microfarad is equal to lower left capacitor. So that means it is again storing a plus 15 microcoulomb and minus 15 microcoulomb here. Yeah. Okay. So now what you have to do is observe carefully one more time that these two set of pairs of plates and these two set of pairs, minus 10 microcoulomb and plus 15 microcoulomb, minus 15 microcoulomb and plus 10 microcoulomb. So let me rewrite this scenario in a different pattern. Okay, so let me rewrite it. Okay, so please write, I'm having the upper plate of the capacitors like this and lower plates of the capacitors like this. and we are connected A and B like this. This is A point and this is our B point. How much charge is stored, right? So I should rewrite, okay. So how much it is? It is minus 10 microcoulomb, and this is a plus 15 microcoulomb, and this one is minus 15 microcoulomb, and this one is plus 10 microcoulomb, okay. So only these plates I have written. The net charge here is plus 5 microcoulomb, and net charge here is minus 5 microcoulomb. This means there is a excess of electrons in the bottom, okay. Here here excess of electrons, are here. So electrons would flow, right? So when you connect the switch, electrons will flow in this direction. So flow of electrons happen in this direction. So we will treat some convention. Okay. So what our convention is? Our convention is, oh, positive charges will flow in this direction. It is our convention. Convention. Right. So our convention is like this. So let us do what actually the amount of charge that flow. Okay. So a charge of 5 microcoulomb that flows. Right. So minus 5 microcoulomb when I divide it by 1.6, of course, minus 1.6 into 10 power minus 19 coulomb. Probably I get what? I may get something like this 31 uh, 250 into 10 power 9 electrons. Roughly 31,250 billion electrons will flow in downward direction. That means from A to B. A to B. So this many number of electrons will flow from A to B. Conventionally, what we do? So conventionally, we simply take what? 5 microcoulomb, that is plus 5 microcoulomb flow from B to A, right? So B to A, this is our convention. So that's why our answer in the question is na, plus 5 microcoulomb is flowing from B to A. This is our convention, right? So that is what we have to choose in the option. So 5 microcoulomb from B to A is correctly said in which option? It is correctly said in this option, right? So 5 microcoulomb from B to A. This is our answer. Okay. So I hope you understood. I said the solution in much detail. You can understand how and what is happening here. Thank you.